Technology Reimagined. Join us as we explore the exciting world of tech and how it's changing everything from our daily routines to influencing the strategies of businesses large and small. I'm Chris, and joining me is Ray Zazzo, Strategic AI Advisor with the Zazzo Group. And we invite you to join us on a fascinating exploration of artificial intelligence at the cutting edge of technology. So, Ray, what exactly are we going to discuss today?
I thought we can have a deeper discussion as to how AI works. Making machines intelligent, able to learn, reason, and make decisions is no small task. Training AI models requires a lot of computing power, sophisticated algorithms, and data. These models use complicated algorithms, similar to advanced math equations. And solving these equations requires a lot of brain power, or in this case, massive computing power. AI models learn through trial and error, like a child learning to ride a bike. They make predictions, see how they did, and adjust their approach. This iterative process needs a lot of computing power to be efficient.
Can you tell us what's the big deal with computing power?
Computing power is the fuel that powers AI development. But it comes with a big price tag, both in money and the impact data centers have on the energy grid and the environment. Without this computing power, training advanced AI models would be like trying to count all the grains of sand on a beach by hand. Slow, inefficient, and likely impossible. By now you've heard of NVIDIA. Their powerful graphics processing units, that's GPUs for short, have supercharged machine learning, making it possible to train super smart AI models. Their specialized AI chips are the go-to for training huge language models. NVIDIA's specialized chips and the hardware have become essential to AI development, powering everything from research labs to major data centers. They're basically the foundation that made the current AI boom possible.
We hear a lot about algorithms. What is their importance and how are they used in AI models?
Well, algorithms are essentially recipes for problem solving. They provide a step-by-step set of instructions that computers follow to complete tasks. Without algorithms, computers would be useless, unable to perform even the simplest calculations or logical operations. There are several training methods used to train algorithms that I'd like to briefly touch on, starting with supervised learning. Think of it like training a dog with treats. We show the AI labeled data, like pictures of cats and dogs, and reward it for correct guesses. This is great for tasks like image recognition and spam filtering. Then there's unsupervised learning, which occurs when an AI explores data on its own, like a kid playing with a new toy. It finds patterns and relationships without any guidance, which is helpful for tasks like customer segmentation and anomaly detection. We've got semi-supervised learning, which is a mix of both. We start with a small amount of labeled data and let the AI learn from the rest of the unlabeled data. This is helpful when labeling data is expensive or time-consuming. There's also self-supervised learning, which is when an AI learns by predicting missing parts of the data. It's like filling in blanks of a sentence. This is common in natural language processing and image recognition. But I'm not done. There's reinforcement learning, which is like training a pet with rewards. The AI learns by taking action and getting feedback. This is used for tasks like game playing and robotics. Transfer learning is when we take an AI trained on one task and adapt it to a similar one. It's like learning a new language by building on your knowledge of another language. Active learning occurs when the AI is smart enough to ask for help with the toughest examples, making learning more efficient. And there's just a few more here. No pun intended, there's few-shot and zero-shot learning, is when AI learns from very few examples or even without any examples. It's like learning a new word from context. And the last learning I want to touch on is ensemble learning. It's when we combine multiple AI models to achieve better results, similar to getting advice from a team of experts. And then combining these techniques allows us to create powerful AI models that can solve complex problems.
Wow, you covered 9 training methods. There is supervised, unsupervised, semi-supervised, self-supervised, reinforcement, transfer, few-shot, zero-shot, and ensemble learning. In the previous episode, you mentioned machine learning, deep learning, neural networks, and large language models. Can you briefly explain these concepts to our audience?
These are all related concepts that complement or overlap with the training methods I just mentioned. Let me explain how each fits into the broader picture. Imagine you're building a super smart machine. You start with a basic blueprint, that's machine learning, which allows the machine to learn from data. Then you add a powerful engine, that's deep learning, that lets the machine understand complex patterns, like recognizing faces or understanding language. There are tiny interconnected parts called neural networks inside this engine. These networks work together, processing information layer by layer like neurons in our brains. Then there are large language models. These are supercharged neural networks trained on massive amounts of text data. They generate text, translate languages, and even write creative stories. It's like having a super smart friend who's read every book. But first, we really need to gather a lot of data. And once you have the data, you can feed it into the machine and let it learn. As the machine learns, it adjusts its internal settings to improve performance, like tuning a musical instrument to get the best sound. And once that machine is well trained, well, you can test it on new data to see how well it performs. And if it does well, you can use it to solve real-world problems. So that's a basic overview of how these technologies work together and create a powerful AI model.
Okay, so we need massive computing power, sophisticated algorithms, and what else?
That's a great question, Chris. Data is the fuel that powers AI models, and yet data availability is becoming a major challenge. As these models become more complex and sophisticated, they require increasing amounts of data to train on. Additionally, organizations are finding their data just may not be properly structured for consumption. So while these tools are incredibly powerful, they rely heavily on high-quality data to function effectively. And this means that humans are still critical in organizing, cleaning, and updating the information that these AI systems consume. And we're going to talk about the human part of this in a later episode. But all of this has led to concerns about the availability of high-quality data and the potential for these models to become biased or inaccurate if they're not trained on diverse and representative data sets. You may have heard the term AI hallucinations, and that's when an AI model produces incorrect or misleading results in response to a prompt. And these errors, they can range from minor inconsistencies to completely fabricated or contradictory information.
Significant advancements in AI have occurred in the past 2 years. However, concerns have been expressed about data privacy and the lack of regulations. What are your thoughts?
The rapid advancement of AI presents a significant challenge: safeguarding data. The potential for misuse and unauthorized access grows as individuals and organizations share information online. AI models use this data to learn and predict. But is that the risk we're willing to take? Tools like ChatGPT are amazing, but we must be careful what we share. Once you feed information into an AI model, it's out there for anyone to access. AI can analyze our behavior and predict our preferences, but it can also manipulate or discriminate against us. It's a delicate balance, using AI to improve our personal and professional lives without compromising our privacy or security.
What can be done to overcome these challenges you mentioned?
We can't rely on tech companies alone. Their history of app vulnerabilities demands a more robust and ethical approach. First, we need stronger regulations. Consider the General Data Protection Regulation in Europe, a strict law that gives individuals more control over their data. Companies must be transparent about collecting and using information, and people have the right to request their data be deleted. We need similar regulations in other parts of the world. We need collaboration between governments, businesses, and the public. We need clear laws and regulations that protect our privacy, but allow for innovation. Businesses must be ethical and transparent, and we need everyone to be informed and proactive about protecting information. But regulations and laws aren't enough. We all need to be more mindful of what we share. In May of 2023, Samsung experienced a significant data security incident. Employees uploaded confidential source code and proprietary meeting notes to ChatGPT while using the tool for professional tasks like summarizing meetings and debugging software. The breach raised critical concerns about intellectual property protection when using public versus private AI platforms, ultimately compelling many organizations to develop training programs and a more stringent set of guidelines for using AI tools in corporate environments.
Clearly, there were unintended consequences that nobody was thinking about at the time. Given that incident, what can organizations do to prevent that from happening to them?
A lot of AI runs on giant servers owned by big tech companies. That means your organization's sensitive data could be floating around, potentially vulnerable. That's where private AI comes in. It's like having your own personal AI assistant, but way more powerful and secure. And instead of relying on someone else's AI, you build your own on your servers or private cloud. This way, your data stays safe and sound within your organization's walls. There are a couple ways to handle it. For example, doing an on-premise deployment, which is like building a computer in your basement. You install the AI software on your servers, which gives you complete control over everything. An alternative approach is doing a private cloud deployment, which is like renting a private room in a big data center. You get your own secure space to run your AI models. AI models could also be trained using a federated learning approach. Instead of gathering everyone's sensitive data in one place, AI models learn from data that stays put on individual devices or servers. It's a clever way to develop smarter AI while keeping private information private. Kind of learning from experience without sharing personal secrets. Each organization trains its model on its data, and then we combine the results to create a powerful, shared model.
What else should organizations be doing?
And to make it even more secure, you should be encrypting your data, so even if a bad actor breaks into your system, they can't easily access the information. However, it's worth understanding that encryption is part of a broader security strategy, not a complete solution. You should also control access to your AI by implementing robust access controls and permissions to manage who has access to your AI model and what they can do with it. As organizations continue to navigate the complexities of AI adoption, private deployment strategies represent a critical step towards responsible and secure AI implementation. We're nearing the end of today's episode, so let's recap. AI is the art of infusing machines with intelligence. It's like training a digital mind, empowering it to think critically, learn from experience, and adapt to new situations. AI systems require significant computational resources to train and deploy complex models. This involves high-performance computing hardware and specialized software framework. But the real magic happens with algorithms that teach AI how to learn, and there are several methods, including supervised learning, where you guide the AI, unsupervised learning, where it figures things out on its own, and reinforcement learning, where machines learn from experience and adapt to changing environments. Remember, data is the fuel that powers everything. But here's the catch. We can't just grab any data and dump it in. We must be careful about privacy and ensure we're not accidentally teaching AI biases. The whole AI world is a balancing act between incredible technology potential and responsible development. And we're trying to create something extraordinary without making it a mess. If you're as intrigued as I am about where AI could lead us, I encourage you to explore further. Read some articles, watch videos, even take a beginner's class and test drive tools like ChatGPT, Gemini, Claude, and Microsoft CoPilot, just to name a few. You'll be amazed at what these tools can do. And of course, please stay tuned for an upcoming episode where we'll discuss what tech companies are doing to address the AI ethical landscape. And as we wrap up, here's something to consider. The full potential of AI remains shrouded in mystery. We're only beginning to uncover its capabilities and the transformative impact it'll have on our world. How will AI continue to evolve, and what will that mean for us?
AI is already reshaping our world in incredible ways, but we're only at the beginning. Thank you for tuning in to the show, and we look forward to having you join us on the next episode of Technology Reimagined.